morning. Testing, testing. 1, 2, 3. How is everybody doing this morning? Greetings and good morning to the 11 people who are viewing this first lecture of our last week of classes for this semester. Thank goodness. Is it a little quiet? Hello? Maybe. Turn it up just a little bit. There we go. Hello? Test, 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 test. Test! Okay. Cool. So, nothing really to report at this point in time, so why don't we just get right into our lecture material for today, and maybe we can finish off databases today. Who knows? So, if you all recall what we were talking about previously on this your favorite class. Good morning. There we go. Some person said good morning. So, we were working on this this database of movies. Ostensibly, what we're doing is we're creating a movie video store rental database. So, a computer system that would be referred to at a point of sale terminal inside of a video rental store. We've got a, at the moment, we've just been performing some basic operations over one specific table, a table of movies, including title, genre, rating, and a movie ID number. So just to recap very quickly, in order to create a table, you must use the create table keywords, give the table a name, provide a schema. A schema is a a parenthesis delimited, comma separated list of essentially your column names associated with data types. I know associating things with data types is something that is uncommon for a person who has only thus far been working in Python, if that is in fact the case in your case. However, it bears noting that this is actually a very common construction across many, many programming languages. It is in fact the exception, not the rule, that you would not have to include the data type when specifying a list of arguments. So this should be, if you're used to not Python, then this would be a very natural construction for you. So that creates the table, but that doesn't populate it with any data. In order to actually put data into the table, you use insert into, specify the name of the table, and then you put values, whichever values you wish. So there you go. That's how you put stuff into a table. Having put stuff into a table, you can then view the stuff that's in a table, and I believe this is where we left off. So if we select star, which means all, from movies, which is our table name, you can see we get a listing of all of the entries in our movies database. And just to illustrate one additional point here, one of the interesting things about databases is that when you insert a record into a database, you don't actually have to have it complete. It does not have to be complete. You can enter in partial records. You may have noticed in the last lecture, when I was entering data into this table, I left out this bit here. I was just insert into movies, values, and then we would provide some values like 105, Pokemon, the first movie. genre is Pokemon, and rating is very G. Oh, I misspelled insert. So you notice this operation works without, you can see it's in there, right? You can insert without this phrase here, right? Without this listing of the title, or of the column names. But, so what's the purpose of it? This comes into play if you want to enter incomplete data. The problem with entering incomplete data is you don't, the computer can't tell which columns you want to skip, right? It can't just, magically read your mind and tell what columns you don't have data for and what columns you do, unless you actually specify that. So the way that SQL chooses to handle this is if you specify an incomplete list of the field names, it will only populate, like that will, and then you provide not, you provide a number of arguments equal to the number of field names you provide. This tells SQL which columns you wish to populate and which ones you don't. So if we have movie ID, title, leave off the genre and just do rating, and we fake up some new data. Let's say Far Cry 3, which I know is a video game. Call it a video game. Whatever. If we take a look, you can see there it is. Notice that the whereas most of these guys have something specified for the third column here, in the case of the one that we just entered, it's just blank. It's just a null value. So that's fine. Any questions about that so far? You decided to sleep in today a little bit today. Well, as long as you're still on time for class, then, that's fine. Yes. Oh, man. It's like... Yeah, our household has suddenly become one in which the concept of sleep has become nebulous. I now understand why, like, if I may be forgiven a brief digression. You ever notice how, like, people in their like 40s and 50s seem to not need any sleep, It's like, oh, I just, I got 4 hours of sleep last night, so I'm good. It's because they learn how to do that when they have kids. This is my new theory. Because this is kind of what's happening in our household. It's like you can these fantastical ideas about getting 7 or 8 hours of consecutive sleep are you can kiss them goodbye. So you have to learn how to be functional with very little sleep. But it's a skill, right? So once you've learned how to be functional with very little sleep, then there you go. You have a new skill. Also, I have a feeling, like, I used to never be able to sleep on airplanes, but I kind of have a feeling that now, if I tried sleeping on an airplane, I'd probably be able to do it. Just because, it's like, no, you sleep now, regardless of whatever. Just sleep. That's how it works when you have a newborn in your house. At least that's been my experience of, like, 10 days of it so far. Anyway, so when we're using the select statement, you'll notice that it says select and not something like show. The idea behind that is that you're being a bit choosy. When you do select star, then, like, this is the least choosy form of this query, right? Because it just shows you everything. But the select command has a just a plethora of different options on it that can help you to refine your query, refine the data that you get back. You should think of it less as a view function and more like a search function. So the first thing that you can do is you can have the database only show the specific columns that you're interested in. So for example, I think we did this already, but for example, if you did title and rating, you would get just the titles and ratings. Fine, good, excellent. It's a little bit, it's not so useful in this particular example because, you know, we're only dealing with 4 columns to begin with, so to only need to, to think that we require that to be winnowed down to just 2 columns is a bit facile to begin with. But, you know, imagine a situation where you have a database that has, you know, 78 columns, which, you know, when you start getting into real applications, that's very, like, think about how many columns a spreadsheet might have, you know? You can easily start getting up into those levels with databases. So the ability to only view the particular columns that you're interested in, that can be very useful if the, you know, if it would take, you know, 10 computer screens to be able to print all of your data. That's useful. We can also refine the search by excluding certain entries based on Boolean logic. So, this is the introduction of the where keyword. So, if we wish to select title and rating from movies where movie ID is greater than or equal to 103, well, actually, you know what, let's actually view the movie ID there as well, because how can we tell otherwise? But you can see that movie 102 and 101 have not been included in this search result because their movie ID is less than 103. There you go. You can apply Boolean logic to filter your view results. And, you know, you may find that there is a very slight discrepancy between the manner in which SQL represents these Boolean operations and how Python represents these Boolean operations. But normally it's only a syntactic issue. That is to say, the underlying Boolean operation itself will remain the same. It just might be off by a character or 2. So there you go. And actually, I think the difference between SQL and Python is minimal, just off the top of my head. That's good. So, another one that we have, which is kind of interesting, is quote-unquote fuzzy matching. So, rather than existing in a world of purely strict equality and inequality, we have an idea of being able to do partial matches over strings. So, where, let's say, genre is equal to comedy. There's the difference right there. So in Python, you would use double equals. In SQL, single equals does the trick for a strict equality comparison. So the only movie in our list which is just comedy is Life of Brian. However, if we say where genre is like comedy, and we insert %, which is a wildcard character for partial string matching, you can see we get Back to the Future, Monsters Incorporated, and Life of Brian, each of which have comedy in their genre string. So this is the correct way of thinking about this is the % denotes some number of characters not matching this string. So if I left off the first one and we just had the wildcard character at the back, notice that Monsters Incorporated is excluded from our results. That's because the way this is formulated, comedy must appear at the beginning of the string. Similarly, if I remove the % from the back and put it on the front, that excludes Back to the Future, because comedy, like, there are non-matching characters after the characters that constitute the word comedy, in the case of Back to the Future. And if you don't put a wildcard in there to catch that case, then it excludes that result. So, yeah, fuzzy matching, basically. Any questions? Nope? Okay. All right. One final thing is we can also order our results. So, you know, again, it seems somewhat facile in a list this size, but if you have a large list and you're trying to find data quickly, it's useful to have a built-in sorting function. So, order by, you then have to specify which field you want to order by, so let's say title, and then you can specify ascending or descending, and if you just leave it, it assumes descending. I think that's descending. Nope, that's ascending. So it assumes ascending by default. So there you go. And you can see that in cases where it's dealing with a non-numeric field, the order by operation is automatically placing things in lexicographic order. That is to say, numbers first, then you know, dictionary style ordering. Cool. Okay. So, sorry to do this to you guys, but give me 1 minute. I'll be right back. Sorry about that. Let's see. Any comments? Nope? Okay. So, moving right along. Yes, so in general, I've gone all through this already. But there are 4 things that you, in general, should be thinking about selecting. A, which fields you wish to view. B, which table you wish to view them from. C, which rows you wish to view. So you wish, do you want to filter the entries? And 4, do you want to sort the entries? Cool. So, this is all good. This is all fine. But after all, this is a Python course. So, let's learn how to do this in Python. Jupyter Notebook. So Python has a library module, sort of similarly to how Python has a library module for dealing with CSV and CSV and JSON files, you also have a library for database interaction. So, I think I can just access it. Is it in this? It is in this folder. Good. So, if we import our SQLite 3 library, we can then interact with a database in the same way that we interact with a file handle, more or less. There are a few caveats. It's actually kind of, like, from a practical standpoint, it's kind of like a combination of file handles and interacting with the pyplot, the matplotlib stuff from a couple of lectures ago, if you remember that. It kind of feels like something between the two of those, because A, you are actually interacting with a file, and B, you're kind of making modifications as you go to a thing, at any rate. So, database is equal to sqlite3.connect videostore.db. And then, of course, when you're finished, you always want to close it. And that executes, no trouble. So, if it executes without trouble because this file actually exists, I think, unless it just creates a new one. If you specify one that doesn't exist, yeah, it probably just created a new one. Let's see, it did. Yes, there we go. Actually, I misspelled it even, so let's see here. Originally with a uppercase. Okay. These are the types of things that really, like, you have to pay attention to these types of details when you're programming, because these, like, this is the real stuff, you know? This is the stuff that you'll spend, like, 2 hours on a test trying to figure out what the problem was, and it was because you misspelled the file name or something stupid like that. So, one thing to keep in mind when you're interfacing data between SQLite 3 or other databasing software and Python, there's a slight incongruity between the data types inside of the database and the data types inside of Python. Integers correspond to integers, as you might expect. What SQL calls a real, in Python we call that a float. What SQL calls a null, we call a none. And both text and date data types are both expressed as strings inside of Python. And so, what you do not get, for example, is the SQL library automatically dipping into the datetime library to be able to construct datetime objects from data types in SQLite 3. If you want that, then you're going to have to do it yourself. And isn't it great that we learned all about the string formatting and parsing functions when we talked about dates? There we go. So, when we're working with a database file in Python, we must distinguish between the database handle itself and the quote-unquote cursor. In order to actually execute anything, you need to create a so-called cursor object. The cursor object basically is just this guy here, but in code, right? So you can send commands to SQLite. You can send SQL commands via the cursor, but you can't send them directly to the file. Anyway, it's just an intermediate step that you have to do. So cursor is equal to db.cursor. We then may send the commands through our cursor, cursor.execute. And then we express our SQL query as a string. Select star from movies. And what happens then is the results of that query, if it has results, are then stored in the cursor object itself. if you want to get those results, you have to fetch them. You have to use either fetch1 or fetch all, which are kind of like the... yeah, there we go. So notice that when we're printing results from the cursor, this is happening again in much the same way as you would read information from a file. The cursor has this amount of data that it has queued up to give you, and every time you request a line from it, it sort of spits that back up at you and removes it from the things it still has to print. So if you fetch all after having fetched the first one, then you get... like, the first one is not included when you fetch all of them. So there you go. How is everybody doing with this stuff? You guys are pretty quiet in the chat, so... Is it just, are we just getting up there? Nobody really cares about SQL? Maybe? Hopefully, people have some level of caring about the lecture material. Wow, do we only have 17 viewers today? Oh, wow. Like and subscribe. I get it. It's near the end of the semester. Just because I get it doesn't mean I condone it, though. So, anyway. So the other interesting thing is that, just like reading lines from a file, that's something that you can do in a for loop, because the file handle has been set up as an iterable object so that the rows are the things that you iterate over. In the same way, when you get results back from a query, those results are also iterable using a for loop, which just makes things a little bit nicer for you. So if you, instead of doing all this jazz, you could go for entry in rows. So you have to assign, you have to use assignment to get the rows object, but for entry in rows, print entry, and there you go. Those are all our entries. Ta-da! So, question. In tutorial last week, the TA mentioned that we would only be responsible for writing SQL queries on the exam. Is that the case, or will we have to write the Python code as well? In general, I don't like it when, I don't like being obligated to what the TAs say in tutorial about, what this or that will or will not be on the exam, because, in general, that's a thing anyway. In general, no. In general, I don't think I've ever done an exam where you have to remember how to produce this code here. Although, there have been instances where you need to use it, but producing it yourself, not always, not usually. So no, if you're gonna focus on studying for this particular bit, for this particular set of for this topic, for sure focus on the SQL queries themselves, 100%. And to some extent, even if I were to ask you, to use these cursors on the exam, all of the code you want is right here in the slides, and it's an open book exam, so, you could hardly be in a better position for it, shall we say. But yeah. Is there a way to get it so that it doesn't remove an entry? You mean from printing it? Yeah, you just fetch all from the beginning. You could even, where are we? Yeah, if you wanted to not divide it, you could even say data is equal to cursor dot fetch all. And then, you know, if you print the data at that point, you've just got a list of your entries. So you can work with that in any way that you wanted to work with it in Python, right? That's now generalized Python data. Cool. So, yep. If we add the line in red below, the rows we get back will be dictionary-like objects where we can pull out a field by name. So if you add the line db.rowFactory is equal to sqlite.row, then you can access things via dictionary rather than via index. This may be useful to you. You can also insert data using Python as well. So this is kind of an interesting thing. So let's say we had some data we wished to answer. M17 t is equal to beauty and the beast. No, beauty and the beats, for sure. G is equal to animation, musical, agriculture. Row or rating is equal to G, sure, for goodness. So if we wish to insert these values into our database, we insert into movies values question mark, question mark, question mark, question mark. Then we provide a tuple that contains these values. This is not the way that you might... This is not the naive approach. The naive approach would be, oh, well, why wouldn't we just use these guys, construct a string, and then, you know, put that string in? Why do we have to do this business with question marks? Well, the answer is it's safer. So I'm gonna skip ahead a bit and explain why this is better, and then I'll come back to the previous sections. So one of the biggest problems with SQL databases is that just because of the way that SQL works, you have a problem called an SQL injection attack. So it's most of the data loss on the internet is actually due to SQL injection attacks. Most hacks, where, you know how, you know, you'll hear a news story about how Yahoo lost, like, you know, 700,000 account username and account passwords and something like that, or, you know, health, or like the CRA lost, like, you know, 500,000 SIN cards or SIN numbers, something like that. Those types of attacks typically are SQL injection attacks. So it's actually very interesting. These SQL injections are a mechanism for, well, injecting code that isn't supposed to be there into an SQL query. If your database management software is not sufficiently rigorous in trying to sort of remove these types of attacks from queries that get entered into the database, then, you know, basically, a hacker can perform any operation on a database that they want, up to and including viewing things they're not supposed to view, deleting things they're not supposed to delete, adding things they're not supposed to add, and basically like any level of access that you have over the database, a hacker could potentially have that level of access over the database. And of course, when that's people's bank accounts, that's reasonably significant. So the way that this works, generally, is you have to modify the data in a clever way, right? So let me just pull up let me just pull up a blank thing here. It'll be easier to see. So let's say we had a very simple SQL query. Let's say we had a string s, which is something that gets input from the user, right? Which rating do you wish to search? So if we insert a string generated from the user directly into an SQL query, the user can actually put some SQL code inside of this string that, again, puts stuff there that's not supposed to be there. So it does require a slight amount of foreknowledge. It either requires foreknowledge of what the system is asking for or doing, or it requires some educated guesses about the way that the database has been set up. And very often, because this is very common technology, if you have a sufficient amount of experience with this technology, it is definitely not impossible for you to be able to make educated guesses about how somebody has set up their database. So, this is the purpose of this query is to see only those entries that match a particular rating. But what if the person wanted to see all of the entries at once, which is something that the designer of the database did not design. So let's say our string is rating is equal to X or PG. If we close the string and then put or 1 is equal to 1 or some other thing that always comes out true, then what we've essentially done is we've set up a Boolean statement that is always true, because of course anything or true is true, right? And 1 is equal to 1 is always true. So what we've in fact done is we've managed to game the system so that we've managed to game the system so that this guy will always come out. Basically, we'll be able to view everything in there. There was one part that I forgot. After this, you also have to terminate the statement with semicolon. And in SQL, the single line comment is dash dash. So the thing that you have to remember is that when this string gets thrown in, it will be thrown in with the hole that it'll be put in has the quotes in it already. So you have to think of some way of dealing with those quotes, right? But if you anticipate those quotes being there, just commenting out the rest of the line means that anything after this point gets essentially lost to history. So this is a perfectly valid SQL query, which views more of the database than the designers of the database might want. So it doesn't do anything to the file itself, it just doesn't print entries multiple times. Yeah, so select queries never make any modification to the underlying database in any event. So that's an interesting thing, right? But we can go further than that. You haven't seen this yet, but drop table movies. Right? So drop table means delete the movie entirely, or delete the table in its entirety. So once we have the possibility of terminating a statement, we can actually, in the same string, create new statements, right? So we can add as many statements as we want in there, which, again, that means that we have as much power over this database as anybody else would, with, sort of maximal privilege levels. So, drop table deletes the thing, deletes the entire table, so this would be an extremely destructive, this would be a destructive attack that was intending to erase records. So you don't want that. So why am I telling you all this? Well, if you construct the query string just from like normal string concatenation, as you might be inclined to in the naive approach, then you're vulnerable to this. This is a thing that you totally could experience. However, if you use this question mark method, the question marks are automatically checked for, basically, the library checks them to make sure that there aren't code injection attacks inside of them. They look for things like these comment characters, for example, or the adding of clauses, and so that provides a level of security. So you want to use these in general. Cool. Let me just finish the bit on injection attacks then. Yes. So another thing though in Python which helps guard against this type of shenanigans is the cursor.execute method only allows one SQL query to be enacted at a time. So if you tried to do this and you were using cursor.execute, you would be prevented from doing so because there is more than one statement inside of this new query. That would be stopped at that level. However, so that's the safe way. There is also an unsafe way, which is execute script. Execute script is a method which allows the execution of multiple statements in one string. It turns out that it can be useful to enter more than one command at a time. But this leaves you wide open to SQL injection attacks. So generally speaking, the strong preference is for using cursor.execute rather than cursor.execute script. There's also an XKCD comic. Hi, this is your son's school. We're having some computer trouble. Oh dear, did he break something? In a way. Did you really name your son Robert Drop Table Students? Oh yes, little Bobby Tables, we call him. Well, we've lost this year's student records. I hope you're happy, and I hope you've learned to sanitize your database inputs. Wah wah. So, yes, in general, SQL injection attacks are the #1 security threat to web applications. Many large-scale breaches have been due to SQL injection attacks. There's a whole list of these things on Wikipedia, which is kind of fun. So, yes. So, in December 2009, an attacker breached a RockU plaintext database containing unencrypted usernames and passwords of about 32 million users using an SQL injection attack. So that's the other thing. Always encrypt your databases. So you can see the list of these just goes on and on. In early 2021, 70 gigabytes of data was exfiltrated from the far-right website Gab through Sql Injection Attack. The vulnerability was introduced into the Gab codebase by the CTO, apparently. A second attack against Gab was launched the next week. OAuth 2 tokens stolen during the first attack. Yes, so once they get into you a little bit, they can sort of break it open and open up more. Like if they steal data from you, that might allow them to steal more data from you in the future if they get data that allows them into your other systems. So there you go. Ta-da! So this still happens. Just so you know, this still happens. So always protect your databases. See if we have any questions. Always a relevant XKCD. Oh yes. So anyway, so that's SQL injection attacks. Let's just bump back up to relationships. Da-da-da-da. Mr. Moore giving relationship advice again. So in our video example, we had 3 tables that we wanted to talk about, or that we're using to keep track of things, right? We have a table for customers, a table for movies, and a table for which videos have been rented to which customer. Sure. So let's populate a little bit of data. Let's imagine we have these customers who so this is a new table, right? It has a customer ID, a name, and an address column. There you go. Oh! Pardon me. So, we'll create table customers. I'm not going to do it right now just because, we have only 3 minutes left in class. And let's imagine we also had a, that seems to be the same slide. Let's imagine that we had a rentals table as well. So the rentals table contains customer IDs, movie IDs, date rented, and date due. You can tell when these slides were made, eh? So the important part here is that the movie IDs match up to movies in the movie table, and the customer IDs match up to customer IDs in the customers table. This is essentially how we're going to symbolically represent customers and movies and associate those 2 types of data. So if you do a select on the rentals table, you get only the customer ID and not the customer's name or date, name, address, etc., etc. Same goes for the movie IDs. Although we have associated customer IDs with movie IDs, we have not associated customers with movies, if that makes sense. At least not, like we have and we haven't, right? We could, in theory, as human beings capable of a certain amount of data processing ourselves, perform cross-referencing on these tables manually in order to find, okay, so movie 107, what is movie 107? Look it up, okay, it's this one, okay. However, why don't we just get the computer to do the work for us? That's the whole point of the modern age. Get the computer to do the hard work for you. So in SQL, we have what's called a join operation. So we can look at data from more than one table at once. If you select star from rentals and customers, then you'll get data from both of those tables at once. However, that data will still need to be further refined, as we're going to see in the next class. That's right, folks, it's 10:19. Thus ends our second to last class for this class. If there are any questions, please let me know right now in the chat. Otherwise, we will log off and I'll see you tomorrow. Can I get a thumbs up at least? Cool. Excellent. What did the zookeeper say when his pack of pachyderms all caught the flu? Never mind, it's irrelevant. Cool. All right. See you guys later. I will leave on that terrible joke.